Adding and subtracting rational expressions. With all of our rational expressions, we have to think about them just like fractions. So adding and subtracting is no different. In order to add or subtract a rational expression, you have to make sure you have a common denominator. So if you take a look at the first couple of examples, we do have that common denominator. And if you were going to take the fractions like 1/4 plus, and we'll just say 2/4, and add those together, you have your common denominator. So the 4 stays the same. You simply add your numerators. So 1 plus 2 is 3. So the answer is 3/4. Same concept goes for these rational expressions. If you have that common denominator of 2x, you add your numerators together. So 2 and 7 make 9. And then the 2x stays the same. When you do this, the next thing you do is you state your excluded values like always. So x can't equal 0. So just like in number 3, you're going to add these two together. So you're going to say, all right, well, I'm subtracting. I have the common denominator of x squared plus x minus 2. And I'm going to subtract this value of 1. So x plus 3 minus 1 is x plus 2. Okay. And then you're going to want to make sure that it's in its simplest form after you've added or subtracted. So here you have x squared plus x minus 2. This can be factored into, so let's just move up here. So x plus 2 over x plus 2 times the quantity of x minus 1. You always want to make sure you factor everything to see if you can reduce it. So you have 1 over x minus 1 is your final answer. X cannot equal -2 and 1. Always go back to your most factored expression. In number 2 here, I'm going to jump back to number 2. You have a common denominator and you are subtracting. The one thing you have to remember when you subtract is that you have to subtract this whole quantity from 3y. So the y plus 4 is going to stay as y plus 4. It's in your denominator. So then you're going to have 3y minus y minus 8, that whole quantity. So you'll notice you're distributing that negative sign to both those terms in there. So you are going to have 3y and then negative y and distribute it to that, and you'll have plus 8. So 3y minus y gives you 2y plus 8 over y plus 4. And again, just like the other one, you want to make sure that it is simplified as much as it can be simplified. And I can see that we can factor the 2y plus 8. There is an LCD, or a GCF, 2 times the quantity of y plus 4 over y plus 4. And you'll see that those cancel out. So your actual final answer for this problem is 2. And then y cannot equal -4. So that's adding and subtracting when you have a common denominator. When you don't have that common denominator, like these down here, you have to create a common denominator. So we're just going to do a couple of these together here. So like in number 8, you can see that your LCD, that least common denominator that you have, is going to be 24x squared. 8 and 6 both go into 24. And then, the lowest value, the lowest degree on your variable is going to be an x squared. So 24x squared. So the way this works is just like if I had 1/2 plus 1/3. I know my LCD in this is 6. So I had to multiply this by 3 over 3 to give me 3/6 plus, and I had to multiply this by 2 over, not what I want to do, 2 over 2, which will give me 2/6. So now that I have my common denominator, these fractions are the same. I changed the way they look. I didn't change their value. But now that I have that common denominator, I can add my numerators and my denominator stays the same. Same exact concept. I'm going to create a common denominator of 24x squared. So 8x, I'd have to multiply it by 3x over 3x. So that's what I'm going to do. 3x. 6x squared, I'd have to multiply by 4 over 4. Okay, so 3x times 1 gives me 3x. Over, and then 3x times 8x gives me that 24x squared. Plus 4 times this quantity gives me 4x minus 8 over 24x squared. Now I've created common denominators. So now I simply have to add my numerators. So 3x and 4x give me 7x minus 8 over 24x squared. The next thing I look for is there anything that can be simplified? Is there anything that can be factored? And in this instance, there's not. So I'm going to write my excluded values. X can't equal 0, and that's the only excluded value. So let's jump over to number 10, because number 9 is pretty similar to that one. So if we jump over to number 10 here, we see that we have k plus 1, I'm going to make this larger, and k minus 2. In order to make a common denominator for this one, the common denominator is actually going to be, the LCD is going to be k plus 1 times the quantity of k plus 2, or k minus 2, excuse me. Okay, so we don't have, you can't just do a k plus negative 2 or something like that. It's got to be this binomial here times this binomial and this binomial and this one times that binomial. Because sometimes when we had fractions of like 1/3 plus 1/5, the only way to get a common denominator is to literally multiply this denominator by this denominator. So if I have the k plus 1 in this first rational expression, I'm going to multiply numerator and denominator by k minus 2 over k minus 2. Because that's what that rational expression needs. I have k minus 2 here. I'm going to multiply it by k plus 1 over k plus 1. So this first one, I have 2k times this quantity of k minus 2. So we're going to get 2k squared minus 4k over k minus 2 times the quantity of k plus 1. Yep, that would be a 2 I just wrote. K plus 1. Plus, and then I'm going to distribute this k plus 1 times this k. So I'm going to get k squared plus k over k minus 2 times the quantity of k plus 1. So now the next thing I have to do is actually add my numerator. So this whole entire quantity, I'll get 3k squared minus 3k, or excuse me, minus, minus 3k. Yeah, minus 3k. Sorry, my answer key's wrong. Minus 3k over k minus 2 times the quantity of k plus 1. So now what you want to do is you want to factor the numerator, so it'll be 3k times the quantity of k minus 1 over k minus 2 times the quantity of k plus 1. And you're going to see that nothing can be simplified. So the next thing we have to do is write our restrictions. So k cannot equal -1 and 2. So when you're doing these, you need to find that least common denominator that they all have, that the two rationals have. If you look at like number 11, I see you could multiply both of those together. However, one thing you might want to do in the beginning is actually factor it. So you have y minus 8 times the quantity of y plus 8. So you'll notice that you do have a y plus 8 here in this fraction here, in this rational. And then you also have a y plus 8 in this one. So that is a common denominator. So the one you don't have, the piece you don't have, is this y minus 8. So all you need to do is multiply this one by y minus 8 over y minus 8. Keep it as simple as possible. So always find that common denominator, and then multiply to create equivalent fractions or equivalent rational expressions, and then add or subtract your numerators and state your restrictions.